On the home page of the VNC Viewer, there is a button captioned Machine Settings. Pressing this button will navigate to a page where many of the machine control parameters reside. There are no buttons on this page that will cause the machine to move. Rather, there are a number of text boxes that accept numeric inputs. The values determine how the machine moves or what position it goes to. All the parameters in this area at the top of the page determine the speed and position of the butterfly table during the assembly process. There are 4 columns of parameters that are under the heading MTT. MTT stands for Moving Tilt Table. The moving tilt table is the half of the butterfly that's on the non-operator side of the machine. It is capable of motion in the tilting direction, and it is also capable of lateral motion. There is a shift cylinder that moves the table in and out during the assembly process. There is a column of parameters that control the shift cylinder when it moves in and when it moves out. There are 4 columns of parameters that are under the heading FTT. FTT stands for Fixed Tilt Table. The fixed tilt table is the half of the butterfly that is on the operator side of the machine. It is only capable of motion in the tilting direction. When the moving tilt table and the fixed tilt table go up, their movement is broken into 2 separate moves. The first move is called Up 1. The second move is called Up 2. Up 1 is a rapid move from the down position to an angle that is nearly vertical, but short of the final assembly position. Up 2 is a slower move to a steeper angle where the 2 halves of the IG will be assembled. The down move for both tables is also broken into 2 moves. The down 1 is a slower movement that takes the table from a very steep angle to a shallower angle. Down 2 is a rapid move from there to a fully down position. There are then rows of parameters that define the behavior of each move. There is the velocity of the move. There is the set position of the move, the acceleration used in the move, and the deceleration used in the move. The way this would read would be: move the moving tilt table up to 87 degrees at a velocity of 10 inches per second, accelerating at a rate of 15 inches per second squared, and decelerating to position at 5 inches per second squared. After the table is up to position 1, move the shift cylinder to a position of 28.683 inches at a velocity of 10 inches per second, with an acceleration and deceleration of 5 inches per second squared. After the table is shifted in, move the moving tilt table to its second up position of 90 degrees at a velocity of 1 inch per second, with an acceleration and deceleration of 5 inches per second squared. Each of the tilt tables is equipped with an absolute encoder on the actuator. The encoders provide necessary feedback to control the angle of the tables. These 2 parameters are the home offsets for the 2 tilt tables. The encoders are absolute encoders, so they don't need to be homed. The home offsets for the tilt tables is simply the opposite of the raw encoder counts when the tables are in the down position, meaning if the value is negative, the home offset is positive, and vice versa. Triples are a little trickier to assemble than doubles. The biggest reason is that the center light of the triple is elevated above the outer lights. When you slide the bottom over, the center light becomes even more elevated. When the top is pushed over, the bottom contact acts like a hinge, and the bottom of that unit is not properly aligned. The way to combat this issue is to first position the 2 halves of the IG as close to each other as they can get without contacting each other. Next, we execute the move Up 2 on the moving tilt table, which takes it up to 90 degrees and causes the top of the unit to fall over. When the swing arm slides the bottom over, the alignment is now good. While it is imperative to have the top of the triples fall over, it's not necessarily beneficial for a double to fall over. For this reason, the set positions for Up 1 and Up 2 are divided. There's a capability to create 2 different profiles between doubles and triples. Now back to this group of parameters. As stated before, these parameters allow for fine-tuning of the assembly process. The first parameter is to adjust the min butterfly set-down position. The min butterfly set-down position defines the position of the shift cylinder when it has reached the first valid position where the lift bar is fully under the unit on the movable tilt table. As you see here, the table is not shifted over far enough for the lift bar to be completely under both lights. Now the shift cylinder has been positioned so the lift bar is just barely under the unit on the moving tilt table. The current position of the shift cylinder is the value that should now be entered into the min butterfly set down position parameter. You can read what the current position of the shift cylinder is by pressing the home button and navigating back to the home screen on the VNC viewer, then pressing the servo butterfly controls button. This shows the actual position of the shift cylinder. This value is read-only. For more details, see the video on our YouTube channel regarding how to set the minimum butterfly set-down position. To navigate back to the machine settings screen, press the Home button, then press the Machine Settings button. After the minimum butterfly set-down position is set, the next parameter to set is the IG unit thickness at min butterfly set-down. The IG thickness at min set-down parameter is the overall finished thickness of a fictitious unit that would be assembled when the table is in position at the minimum butterfly set-down position. So now the machine knows the thickness of a unit that would be assembled at the minimum set-down position. When a thinner unit is assembled, the shift cylinder will move in further by the difference in thickness between the two units. If the two halves of the IG are too close together or touching, decreasing the IG thickness at minimum set-down parameter will create more separation, and increasing the parameter will decrease the amount of separation. The last parameter of this group that we're going to set is the max shifter stroke. We saw earlier the best alignment for triples happens when the two halves of the IG are positioned as close as possible together. There is, however, a limit to how far we can bring the moving table in. There comes a point where the drive roll on the moving side of the table will hit the spacer, the glass, or both on the fixed table. When this happens, it will cause the glass on the fixed table to tip and fall over. Therefore, we need to determine the maximum safe distance that the moving table can transverse in, and then we need to set the max shifter stroke parameter equal to that position. Once this is done, the table position will be dynamically set to accommodate various unit thicknesses, as long as the shift cylinder does not exceed the max shifter stroke. The last parameter on the screen that pertains to the butterfly table is the single unit thickness. The single unit thickness window parameter is used to determine whether two units can be assembled at the same time. If the parameter is set to 0, the WinIG calculated thickness must match exactly, or the units will be processed separately. If the parameter was set to 10 thousandths, a unit with a thickness of 760 thousandths of an inch would be processed along with a unit of 750 thousandths of an inch. If this parameter is set too high, it could cause some misalignment issues due to uneven pressure from the swing arm. Another variable that needs to be set is the machine configuration. This is set through a pull-down menu. The ALTAS machine options are for a straight line configuration, or it can have an XY conveyor that makes a left turn or a right turn. The Units and Language pull-down menu allows for the machine units of measure to be configured in US standard or metric. The squaring timer keeps conveyor 3A running in reverse for a short time after squaring PE1 is tripped at the end of the squaring process. When making triple pane units, the outer light will transfer into the topping station, and then conveyor 3A will run in reverse to drive the light into the side stops to square the outer light with the center light, which is suspended above. Generally, this is set to 0 milliseconds, but it could be used if necessary to ensure precise squaring. The touchdown height is not a parameter. During the machine setup, you will need to lower the machine topping station to set the level of the lifting cups. Once the height is determined, you can enter the value of the touchdown height. This is simply a place to store a number that you may wish to refer to again later. Once again, the number does nothing to the machine. The next parameter is called the conveyor slow timer. There's a photo eye located at the end of conveyor 12. While conveyors 11 and 12 are unloading, they run at fast speed until the photo eye at the end of conveyor 12 is made. The conveyors then slow down to match the oven conveyor speed. With the conveyor slow timer set to 0, conveyor 12 runs at fast speed as soon as the back of the lead unit clears the photo eye. Any trailing unit will then collide with the leading unit. The conveyor slow timer adds a dwell time before conveyors 11 and 12 return to fast speed. The next parameter we'll discuss is called the washer single load size. This parameter helps the PLC interpret the input signal received from the washer loading sensors. There are two ultrasonic sensors located at the entry of the washer. They detect where and when a light has been loaded. There are also two LED lights. The lights turn green to indicate where the next light is expected to be loaded. If the light is fed into the wrong location, the light turns red and puts the washer into a creep mode. At some point, a light will be wide enough to trip both sensors. The washer single load size parameter lets the program know that the trip of the second sensor is not a misload on the wrong side of the washer. The parameter named short unit size is used only for lines with an XY conveyor. Units narrower than this parameter must be rotated by hand before going through the oven and press. The butterfly pull-down menu allows you to choose the units that the maintenance position and actual position fields will be displayed in. The choices are either angular degrees or linear inches for positioning the fixed tilt table and moving tilt table. The Cycle Times button displays the assembly time for the last 10 units produced. The last two buttons on the screen are the Backup and Restore buttons. The Backup button writes all the parameters on this page to a flash drive installed in the PLC rack. The Restore button reads all the parameters from the flash drive and writes them to the PLC. That covers all the items in the machine settings screen.